Welcome to my YouTube channel. So first of all, thank you all of you guys. You shows your love. So for that, thank you everyone. So today I will briefly discuss the uniform continuity. First, we discuss the definition. When a function is said to be uniformly continuous on a set, and when it will be not uniformly continuous. So for that, first we discuss the continuity of the function f of z. So if z is continuous and z0 belong to S. So for that, it will happen for epsilon greater than 0, there exists delta greater than 0, such that z minus z0 less than delta implies f of z minus f of z0 less than epsilon. Whenever this will happen, so we call if z is continuous at this point. So if this total case will happen for each z0 belongs to S. So if this case happen for each point of this S, then we say fz is continuous on S. So whenever this will happen for all z0, that is if a function is continuous at each point of this set S, then we say this function is continuous on the set. And uniformly continuous, here delta is dependent on this epsilon and also this point x0. So whenever delta become dependent only on epsilon, not on this point, then we say fz is uniformly continuous, that is UC. So for that, definition will be for any epsilon greater than 0, there exists delta greater than 0 which is dependent on only epsilon, such that for all z0 and z belongs to S, z minus z0 less than epsilon imply modulus fz minus f of z0 less than epsilon. So whenever this happen on for every z0 from this set, then we say fz is uniformly continuous on this set. Okay? So now we discuss when the function is said to be not continuous at a point or not uniformly continuous on a set. So first, fz is not continuous at z0 belong to S. So this is not continuous. So for that, first choose epsilon greater than 0, then there exists delta greater than 0, and if you can find, so this will be not continuous on a set S. Okay, so if we can find a z0 from this set such that at this point this function is not continuous, then we say this function is not continuous on the whole set. So if we can find z0 belongs to S such that z minus z0 less than delta, which imply f of z minus f of z0 greater or equal to epsilon. So whenever this happens, then this function will be not continuous at this z0. That means this function will be not continuous on the set. So now we discuss the non-uniform continuity. So fz is not uniformly continuous on S. This means for any epsilon greater than 0, there exists delta greater than 0, and if you can find z0 and z from this set such that whenever this inequality hold, but these imply that greater or equal to epsilon. So whenever you can find 2 points from this set such that z minus z0 less than epsilon, which does not imply modulus of this less or equal to epsilon, that is this will imply greater or equal to epsilon. So whenever we can find such z0 and z such that this will be happen, so then we can say this function is not uniformly continuous. So on this basis I will solve a problem, so which is very important for mid semester examination. So let's see. So consider fz equal to z square. Z belongs to set of complex numbers, and first fz is uniformly continuous on this set. There z such that mod z less than r is a positive real number, and second problem is fz is not uniformly continuous. So this is uniformly continuous. Though this fz is uniformly continuous on this set, but not on the whole set C. So for that, first we prove that this is a uniformly continuous function on this set dr. So this is dr mod z less than r. So for that, first we choose 2 points z and z0 from the set there. Okay, so whenever z and z0 belongs to this, that is z0 belongs to dr, this will satisfy this condition, that is mod z less than r and modulus z0 less than r. So now we find fz minus f of z0, that is equal to z square minus z0 square. So this can be written as z plus z0, this is z minus z0. Okay, this will be, so from this we can write z plus modulus z0 and this will be z minus z0. How we can write this? As we know, z1 plus z2 modulus less or equal to modulus z1 plus modulus z2. So we apply this here on this modulus z plus z0. So from this is less than r, modulus z this is less than r, and modulus z0 this is less than r. So this becomes 2r and this is z minus z0. Okay, this is one. So we'll discuss after that. So the one equation is this. So we get this. So now for any epsilon greater than 0, we can find a delta which is equal to epsilon by 2r. Okay, therefore from 1 we get f of z minus f of z0 less than, that is less or equal to 2r z minus z0, this will be less than. So here we choose as z minus z0 modulus less than delta, and we choose delta equal to epsilon by 2r. So from this we get 2r into this is delta, this is delta, so this will be epsilon by 2r. So from this we get this is epsilon. So whenever, so that means z minus z0 less than delta, that is equal to epsilon by 2r, this implies that modulus fz minus modulus f of z0 less than epsilon. So this means that fz is uniformly continuous on this dr. How? As first we choose z and z0, any 2 points from dr. So this z0 and z is was the arbitrary elements from this dr. So if we choose any point from dr, similarly we can get that this inequality hold for this modulus z minus z0 less than delta. So from this we can conclude that this fz is uniformly continuous on dr. So now we will show that this fz is not uniformly continuous on C. So dr was z such that modulus z less than r. So this was the disk, circular disk centered at 0 and radius r. So in dr, these points are in this disk, but now we choose 2 points from entire field C. So to show that this function is not uniform continuous, so we have to find 2 points for which z minus, that is z0 less than epsilon will imply that f of z minus f of z0 greater or equal to epsilon. So we have to find such z and z0 from the field C. Then we can say this function is not uniformly continuous on this C. So for that we choose 2 points. One z, that is equal to r plus 1 by r. If we take point on circle, so then for that point the modulus z equal to will be r. But in dr there is such point z such that z belongs to r. So on this circle, the points on this circle are not contained in the set dr. So we choose r plus 1 by r. This is outside of this disk dr. So if we take point on this circular path, then it will become z equal to r, but we choose outside of this point, so we take 1 by r, so which is outside of this disk. And another point z0, we take 1 by r, so whenever we take this, so z0 modulus z0 obviously less than r, as 1 by r is less than r. Okay, so this is from inside dr. So we take 2 point z and z0, one from outside of this disk and one which is inside this disk. So for that we get z minus z0 equal to this minus this, so this will be r, so which is delta. Okay, so now for epsilon greater than 0, for epsilon greater than 0, we find fz minus f of z0, that is equal to z square minus z0 square, so which is equal to z plus z0 into z minus z0. So this is, as r is real number, so real positive, we discussed that this r is real positive, so therefore this z plus z0 equal to this, that is r plus 2 by r, that is this plus this will 2 by r. So whenever we take modulus, so this will get r plus 1 by 2 by r, so this will be r plus 2 by r, and this is r, so we multiply this, so this will be r square and this will cancel out, that is 2. So this is clearly greater or equal to 2. Okay, as this is positive, so this is always greater than 2. So we found 2 point z and z0 from c. Okay, these points both belongs to c, such that z minus z0 equal to r, and this modulus value is greater than 2. So from this we can conclude that fz is not uniformly continuous on C. So this is the proof. So this is very important for your exam. So thank you for showing your love. I will expect more likes and comments. Share with your friends so that they can be benefited from my lecture videos. Thank you very much. Like and comment कर देना वीडियो पे, तो मुझे लगेगा कि तुम लोग देखे हो. So for today that's it.